Waiting on you.
Yeah.
Okay. So on this is number 65. It is class period dos. It is 128. So for a rhombus, we are going to put in our new information. So like I said, a rhombus is everything a parallelogram is. It has opposite sides that are congruent, opposite sides that are parallel, opposite angles that are congruent, consecutive angles add to make 180, diagonals bisect each other. Not only do the diagonals bisect each other, but for this, your diagonals are, they're not congruent. Oh, they're perpendicular. Sorry. Diagonals are perpendicular. So I'm going to use the upside down capital T. So perpendicular is upside down capital T. They will use that symbol on your EOC. That means that this makes 90 degrees where the diagonals crisscross. The next thing that we're going to write is that our, so we have 90 degrees. The diagonals make angle bisectors. So diagonals are angle bisectors. So in each corner, each angle is splitting in half, which is nice. This is what you guys were trying to do on a parallelogram. So if you have an angle on one side, the angle matches directly next to it, which is nice. And then the only other property that a rhombi has that a parallelogram does not have specifically is that it has 4 congruent sides. So for numero, yep, so they're all equal. So for number 1, JK is 12. JN is 7. Where else can 12 go? All the sides, because it's congruent all the way around. So it's like a square. It's like a zesty square. Okay. It's a little tilted. Okay. So 12 can go at the top, 12 can go at the bottom, but 12 can also go on the sides because all the sides are the same. Okay. So we have a little zesty square on our hands. 7 can go where? No. Inside where? And L. 7 cannot go here. So the diagonals bisect, but they do not, they're not congruent. Using your eyeballs, you should be able to tell that this one is longer than this one. So they're not the same. Okay. So how much is JM? 12. How much is JL? 14. We need to find MN. It is not 7. It has to be more than 7. Pythagorean theorem. The reason why is because inside you have 90 degrees. So you really have a cute little triangle. More specifically, you have a right triangle. So to find this length, I'm going to kind of draw it off to the side. We have 90 in the corner. 7 is the base, because if you turn your paper, 12 is what piece of the triangle? It is C. So 12 is the diagonal. So 12 is my C. And then we're going to do the Pythagorean theorem like we've been doing for the rest of our lives. So a squared plus 7 squared equals 12 squared. So this is where you square them. And then you're going to have to minus the 7 squared to both sides. So in a calculator, 7 squared and 12 squared. Honestly, you should know what those are off the top of my head. Yeah. Yes, you should know those, hopefully. But, you know, some of y'all don't even know your multiplication tables. 7 squared is 49. 12 squared, like he said, is 144. So I'm minusing 49 to both sides. So when I subtract, what do I get? 95. And then if you shift square root, that's where you get that, what he was saying, what teacher was saying, 9.7. So that side is 9.7, and we're going to put it in the picture. The whole point of doing this, it's like a puzzle. So I'm going to put it in my picture. It represents the height of the triangle. So 9.7 goes there. So when you find a piece, you should put it in the picture, because it's going to help you with the next part. So MN, the little piece, is 9.7. How much would M to K be this whole distance?
Four.
19.4 because you multiply it by 2 or you add 9.7 twice because they match. So 19.4.
Yeah.
Yeah. So try number 2. Put your numbers on your picture. So 23 can go around all the sides. 40 is the whole distance, so you can split it. What is that? Is that gummies?
Yeah.
Like 8 o'clock in the morning.
Sorry. Never too late for something. What we're doing?
Number 2. Mm-hmm. How much is GF? 23, because you should have moved your 23 all the way around town. Okay, HF is how much? 20, because it's whole 40, so I cut it in half. GH is not 20. So what am I going to do? You're going to make a Pythagorean theorem. We're going to color in this little triangle. Which one is C? 23. So because you have 90, literally where the H is, this is your 90. You got 23 here. 20 is technically the height. We're finding A or B. It doesn't matter which one. But we're going to do A squared plus 20 squared equals 23 squared. How much is 20 squared? 400. How much is 23 squared? 529. This one I have to minus it. So I minus 400. So A squared equals 129. What'd you get? 11.4. So 11.4 is this piece. 11.4. So how much is G to E? 22.8. Nice. How do we feel? Do we feel okay?
Yeah.
Not too bad. How did I get 11.4? Oh, 11.4 is this piece, the height or the base of the triangle. So it's this piece. So the whole thing is double that. 11.4 would go here. So that whole line is 22.8. Okay, so we're going to cross out number 3 because we don't got to do that because we don't need a million of these. And we have 2 papers today. So cross out 3. We're not doing that. 4 is angles. So we're going to do the angles. This is what you guys were trying to do with all the other shapes. 38 can still jump across the transversal like we did last time. 38 can still jump across to 4. So it could be 4. That's correct. But also on top of that, it can not be 7. It's an angle bisector. So if that's 38, where else can 38 go? 3 and 5. So this is what you guys were trying to do with the other pictures. This is rhombuses and squares are the only time that it's an angle bisector. So they're directly next to each other. Now, how much is in the center in all of these technically?
90.
90. Technically, each one is 90. So 8 is going to be 90. How could I find one of those missing other angles that's in the other portion?
From 180? So 90 and 38.
Yes. Why can you do that?
Huh?
Yes.
180.
A triangle is 180. So if I know that the corner is 90 and the top is 38, how much is left over? 52. So 52 is 6. I'm going to kind of like draw a little arrow. 52 degrees is 6. Then it can be 7. And then where else can it go?
1 and 2.
Yes.
6.
Oh my God. 52, 52. So all the angles match their angle bisectors. So take a second, fill in your little blankety blanks. 1 is 52 degrees. 2 is 52 degrees. 3 is 38. 4 is 38. 5 is 38. 6 is 52. 7 is 52. And then 8 is 90. Okay, so for number 5, we are not going to do the sides. We're only going to do the angles. So they give you one piece of information. So we're going to cross out the sides because I think sides and angles are kind of like cray-cray. So it says ZXY is 34. C to X to Y. So this little piece is 34. So take a second, move your 34 all around your picture.
Flamingo.
Move your 34 around your picture.
I'm sorry.
6, 7.
Brazil.
You shut up.
Oh,
Damn, you heard that?
yeah.
Bro, why would you say that?
That was
No,
you.
I said it.
I said that. Why would you say that?
So 34 can jump across the transversal. It can also go directly next to it. In each intersection, smack dab in the middle where the crisscross is, where the X is, those are all 90. And then one triangle makes, well, all the triangles make 180. You're gonna have to find that missing angle on the by subtracting from 180. Because V literally in the center is 90. And then each triangle makes 180. And once you have your numbers, try to fill out your 3-letter angles.
Why did you cross it out?
Because I didn't want to do the side. Because when you put the sides and the angles on one picture, it just looks a hot mess. So like we did 2 side problems, so we'll do 2 angle problems.
I'm done.
That way you don't have like sides and angles all on the same thing because it just gets confusing. Okay, so in a triangle adds to make 180. So if I have 90 and 34, how much is that missing corner of the triangle? Not 50, 56. So this is 56. This is 56. 56 can jump across to W. 56 can go here. 56 can also go here because they're angle bisectors and they all match. So if you haven't tried yet, try to read your 3-letter angles. Remember, it focuses on the middle. So it's focused on X, starting at W, going to X, and jumping across to Z. So how much is that one? Yeah.
Let's start with the 90, 50, 76.
The next one says WVZ, which is 90, because all the intersections are 90. The next one says ZYW, 56. And then the last one is XYW, which is 56. Did
Oh,
you actually get those right? Or you
Me?
just, yeah.
Oh, yeah, I did.
Oh, okay.
fine.
But you're just, sometimes I don't know if you're just making noises to make noises.
Sure didn't do it right.
Yes, I do. Shut up.
She does like half the time. It's like 50-50.
Yeah, stupid.
Like her grade, 50-50.
Like, you're so annoying. Like, shut up.
I hope you like nice when you get home, bro.
Okay, let's go to the back. Okay, on the back is squares. We're not going to do all these either. We're going to cross out 7.
And 6.
No, we're going to do 6. We're going to cross out 8. We're going to cross out 10. So we have 3 problems left for our notes. So for our notes, let's go to number 6. So for number 6, a square is literally everything a parallelogram is, everything a rectangle is, everything a rhombus is. That makes a square. So you have right angles, you have right angles in the center, you have right angles in the corner, top and bottom match, the sides match, all the sides match, the diagonals bisect, the diagonals are congruent. So for 6, it says ABC is a square, AD is 11. That's all we get. We have to find everything else in this picture. How? Where else can 11 go if it's a square?
All the sides.
Oh my God, all the signs are 11 because it's a square. Okay, we're halfway there. The next thing that we know is 90. Where?
All the
Around E.
Around E. So we got 90s here. Where else are 90s at in a square? In all the corners. So if this is 90, this is 90, this is 90, this is 90. Okay. And if you have the same properties as a rhombus, that means that you have angle bisectors. So if each corner of a square is 90 and it's an angle bisector, how much is it on each side of B? 45. So really you have 45 here, 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 you have 45, 45, 45. So everything is being basically split. So let's start with our angles. So we're going to try to read these. So this is focused on A. So we're looking at this corner. It says DAB, dab. How much is that?
90.
90, because it's the whole outside letters. Take a second, see if you can read the last three. Take a second, try your angles only. You want to try all of them. Focusing on angles right now.
Good sides. What is AC?
Mhm.
A to C. AC.
Okay, if I focus on E, E's in the center. Says AEB, which is 90. And if you have common sense, the middle letter's E and it's in the middle, all those angles are 90. The next one is focused on B. It says CBD. 45. Nice. The next one's focused on A. It says BAC.
45.
45. Okay, so angles are done. That's the hard part. How much is BC? 11. How can I find A to C? Pythagorean theorem. You need a right triangle. You cannot just use one of the small right triangles because you only have the hypotenuse. You don't have the length of these sides. So you need to go all the way across to use the whole right triangle. We're going to use 11 and 11, and then C is what we're trying to find. So we have 11 as our height, 11 as our base. We have to find C for the Pythagorean theorem.
Oh.
Oh, yeah. So 15.56, so 15.6. So that whole distance is 15.6. How much would DB be?
We're gonna do it again now for what?
No, no,
No, we're gonna.
15.6. Because the diagonals, D to B and A to C, match because it's the same properties as a rectangle. Your diagonals are congruent.
I thought they were doing it.
For a rhombus, they're not
Oh,
congruent.
right.
We're on squares.
Oh, yeah, you're right.
So EC is where we would cut it in half because EC is half of it. 7.8. Nice. We're really doing math today. Okay, so 7 we're skipping, 8 we're skipping because we don't need to do a bunch of these. Okay, so for number 9, we're only doing 9 and 11 last. So 9, what should I?
No 10?
So no 10. So we're only doing 9 and 11. So you can scribble out the rest. So for 9, if CDEF is a rhombus, what should I do with these? Yes, because it's an angle bisector. I'm not adding to make 90. Angle bisector is for a rhombus and a square. So these are congruent to each other. Normally we'd have to jump across for them to be congruent, but for rhombuses and squares only, they are angle bisectors. So we set them equal to each other. Take a minute, solve for X. Mm,
They're both like,
you have a big brain.
are you plugging both of them?
No, you can if you want.
Are you gonna be the answer?
No, but I'll get you to like find the answer. So how much is X? Do you? Somebody had a brain fart or a brain epiphany. Sure. Okay, so if I get 7, 5 times 7 plus 1, and 8 times 7 minus 20, they're the same. How much do you get for each piece? 30, is it 36? 36, 36. Okay, so if each one of those is 36, I can think of right now 2 ways to do this. Does anybody think they know a way? Yeah, you could do that. Okay, but if you're,
Can't you fill in the deep? I mean, so.
yeah, because how much is G? Are you thinking a triangle or are you thinking like side to side is 180? Is how much? Okay, good. So this is 90. And then how much is the triangle in total? 180.
Oh.
So you don't need to add the 36s together, technically. You're just using 36 and 90 and you're minusing it from 180 because it's a little triangle. So how much is that little missing piece if I subtract? 50 what? 54. So FED is not 54. FED is all the outside letters. So how much total would FED be if that's 54?
Oh, 54.
108. So the measure of FED is 108 because you got to add it twice because it's that whole corner. Okay, take a second look at 11. Last one. Then we're going to cross off problems on our classwork. We got square hands.
Why don't you know?
Hey, Dina.
No. Watch me, Tyler. What? Oh, wait, it's easy.
What do you do?
You set it equal to itself for like,
No, because then everything's going to cancel.
what?
If you set 7x plus 3 equals 7x plus 3 and you minus 3, it's going to make 0. And if you minus 7, it's going to make 0. So that's 0 equals 0.
So X equals 0.
No.
Sorry.
They're funny, but.
What do you do?
Like add it twice?
Yeah, just double.
Yeah, you could double it. Okay, so if this is 7x plus 3, this is also 7x plus 3. So you could double it or add it twice and equal it to the whole corner. A whole corner is 90. Oh my God, are you a cheater? Oh!
So wait, so this
In my class? Wait, it's in my class?
No.
Mm.
No,
Pick up his me now.
Oh, he's watching.
what is it?
I love catching a cheater. Nothing makes me happier. Like somebody cheated on my midterm. Ooh, cut them for that. Oh, you got a 0. You got a 0 and referral.
Wait, did anyone cheat on your midterm?
Yeah, and I caught them. And I said, not today, loser.
In what period?
I'm not gonna tell you.
Oh,
It was first period.
Love
First
catching.
period.
It wasn't first period.
First period.
it was third period. No,
Yeah,
it was
here,
third
Pablo and
period.
Charlie, there's no way.
Third.
Oh, I'm talking about this year.
Oh, this year.
This year, I caught someone.
It gotta be third.
It makes me so happy.
Was it third period?
I don't know. But I said, not today, loser. You get an F. So minus 6, minus 6. 14x equals 84. What?
I gotta take point.
It's 6.
5.
I don't know. Did you distribute properly? 2 times 7 is 14. 2 times 3. You could have also, side note, you could have just equaled it to 45 because half of 90 is 45. But it doesn't matter because geometry is like, you can do it a bunch of different ways and get the same answer. It does not matter. Okay. So on a classwork paper, we're going to cross out a bunch of these so you don't have to do all of them. So on your classwork, that's because we've been chit chatting and nobody's answering the question. So
you talk too much.
the notes paper you are keeping, you're not turning in online. I did them all for you. You'll get points when you find your check as long as you don't lose your paper, which some of you will lose it for some reason. So on here, you can cross out, you can skip number 3, 7, 8, and 10. So scribble those bad boys out. You don't gotta do that. This will be turned into the bin when you're done. Okay, so you don't have to turn it on a line. So cross out 7, 3, 8, and 10. A rhombus and a square all have congruent sides. So when you find one side, you move it all around. Move it around. No, keep it reminder check.
What?
Yeah.
There you go.
Oh,
Sweetie.
thank you. Yeah, last year, my school year. It's not last year. Oh. Last year. Last year. Yes, 6 years. This is 4. 4.